assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, this problem involves an oscillator with a block that has a mass of 0.5 kilograms. And once it starts oscillating, it has an amplitude of 35 centimeters or 0.35 meters. And it takes 0.5 seconds to repeat the motion. The first thing you're asked to find is what is the period of the block. Since the problem already says that the time to repeat the motion is 0.5 seconds, that actually means that our period is 0.5 seconds, because that's how long it takes to actually repeat one full motion. So they actually gave the period right in the problem itself. The next thing you're asked to find is the frequency, and we are going to use the equation period equals 1 divided by the frequency, and actually instead solve for frequency. So if we rearrange this equation, we get frequency equals 1 divided by the period. So that will be 1 divided by 0.5, which gives us a frequency of 2 hertz. So that is your frequency right there. Part C wants to find the angular frequency. And our equation for angular frequency is omega equals 2 pi f is what we're going to use for this. And so when we substitute in the frequency that we just found, we're going to have omega equals 2 pi times 2, which is going to give us 12.56 rads per second. Okay, next we're asked to find the spring constant, and we're going to use the equation K equals mass times omega squared. We have our mass, which is a given in the problem, which is 0.5 kilograms, and we just solved for our omega, so we're going to have 12.56 squared, which gives our spring constant a value of 78.9 newtons per meter. Okay, our next task is to find the maximum speed, and we're going to use the equation velocity equals omega times the amplitude sine omega time plus phi. Now we know that it wants to be the maximum speed, which means this portion here, the sine, when that is going to be at its maximum is when sine equals 1. So we can essentially ignore this portion of the equation itself, giving us the final equation being velocity equals omega times amplitude. And so when we plug in our values for that, we know our omega, because we solved it earlier, is 12.56, and our amplitude is given in the equation as 35 centimeters or 0.35 meters. So our velocity equals 4.4 meters per second. And the very last thing we are asked to find for this is the maximum force on the block from the spring. So we have to do our force equals mass times omega squared x. And so we're just going to plug in our values. Force equals 0.5 kilograms times our omega, which we solved for, which is 12.56 squared, times our amplitude, 0.35, giving us a force of 27.6 newtons.